Okay, let's start with this simple sum based on the same old concept of the state space. So, Anubhav, you can try this out. Tell me what answer you are getting.
Yes, yes,
What A?
yes, yes.
Okay. Someone else also joined, right? Navkirti. Navkirti, what is the status? Are you trying the sum? Okay, so what answer are you getting? Are you getting A? Just let me know which option you are getting. Navkirti, in your text box or wherever you want to, feel free to write. Okay, so let us discuss the solution. The correct answer is A. So the state space equation is given like this, as was given in the question paper. And from here you can get the A, B and C matrices, and you know that transfer function is given by C into phi s into B, where phi s is the state transition matrix. The state transition matrix is given by Si minus the inverse. We have done this multiple times in the previous sessions, so I don't think it will be a big problem for you people. So if you do the operation, you would end up getting this transfer function. It is pretty straightforward and quite mechanical sum. Let us see if I can give a bit more. 53. Let us do this sum first. Okay. Okay, so this is the other sum in which unit step response of a system has been asked to you. The system has been given to you, and you are asked to find the unit step response of the system. Tell me which of the options would be correct.
Yes, yes.
A. Okay. Why is it A? Anubhav?
So solve करने पे आया.
And how are you solving?
Uh, we can directly check final value by applying final value theorem. So
Hmm?
it is coming 1. Or
Okay.
we can just expand the equation. Transfer function is output upon input. So the output become 1 minus 2s upon s into 1 plus s. And then solving that equation gives us 1 minus 3 e to the power minus
Why?
3.
I mean, why are you not directly applying this initial value theorem? What is the problem? So initial value theorem, what does it states?
Limit s tending to infinity
Hmm.
s into the function, your function.
Yes. So if you do that, what it is coming?
Okay, I am trying to.
Hmm.
Minus 2.
Okay. So actually, for generally when we apply initial value theorem, one thing you should keep in mind is the transfer function has to be strictly proper. Okay, this is a proper function, but it is not strictly proper. It's better to first break it into partial fraction. In this case you are getting, but if I would have given something else, you would have got erroneous results if you directly apply initial value theorem over there. So two things you have to keep in mind. First thing is you cannot apply final value theorem when there is a right hand side pole which would make the system unstable. So at t tends to infinity, the output will blow. So in such a case, you cannot apply final value theorem. For initial value theorem, while applying initial value theorem, first you have to make the given function into a strictly proper function. Then only go for applying initial value theorem. Okay, so I'm showing two ways of doing it. The first is pretty straightforward, in which you are getting the output by multiplying with 1 by s into this transfer function. Now you break this into your partial fraction terms, and after breaking this, take the inverse Laplace transform. So you get yt equal to 1 minus 3 to the power minus t. So if you do this to get the initial value, you put t equal to 0, and then you get yt equal to 0 equal to minus 2. To get the final value theorem, you put t equal to infinity, you get 1. So this is straightforward. Now applying initial value and final value theorem. So you see, in case of final value theorem, what I have done is I have put s is equal to 0. 1 by s and s cancels out. We are left only with 1. And in this case, we are putting this, so this thing is what I was saying. I was saying that for initial value theorem, the transfer function on which you are applying must be strictly proper. So if you are not, if you are given a improper function or some only proper function, you break it into a proper one. You break it like this. So this becomes a strictly proper function. Now you can apply this theorem in this part, and you will get this. So this is something that you have to keep in mind. This is something that you have to keep in mind while applying initial value theorem. There is another one sum. What is the other one? 54, I guess. Yeah, this will be the last sum. Try this out. Tell me what are you getting.
A.
A. Okay. Anubhav, what is the root locus?
The path traced by the curve.
Yes.
The path traced by the curve.
The path traced by whom? Yes.
Yeah, sir. The plot we draw. Hello. The transfer function.
Yes. Who is speaking? Somebody else. Okay. Yes. Tell me, Anubhav. What is a plot that you are drawing? You know a few rules. You draw a plot, but what is that plot?
The plot.
Yes.
Uh,
Yes, Anubhav. I'm listening. Tell me.
so, sir, I am unable to recall. Sorry.
Okay. Okay. So thing is that is what I'm noticing from a long time, Anubhav. Most of the questions you're solving, but the question solving techniques are more mechanical. You have to know what root locus is, or else useless. I mean, see, these are previous year questions. You can easily find solutions in the in any other book. That's why I try to give some insights in the way of solution I am making. I give multiple types of solutions if possible. So this is how I am trying to present. But thing is, you have to understand what root locus is, about whatever what topic you are reading. You have to go into the depth and understand at least. That is important. See, root locus is actually it tells it is the locus of the closed loop poles. When you vary the gain, this k you see, this k as k varies from 0 to infinity, how the closed loop poles of the system is moving in the in the imaginary in the complex plane. That is what a root locus is. So you have to understand what root locus is and what the purpose of the root locus is. Okay. So what is the angle that is made by the asymptote? How do you find the angle?
P minus Z. आज हम डाल 180 upon P minus Z.
180 upon p minus z. Why is it so? Why are you making that thing? Where from Babu got that formula? What is IP? And for breakaway, what is a breakaway point, Anubhav? What do you mean by breakaway point? The question has asked to find the breakaway point, right? What is the meaning of the term breakaway point?
The breakaway point is the it occurs between two successive poles. It is the point where multiple poles lie.
Okay, correct. Yes, you are correct. Yes, you are correct. Yes. So, why that asymptote that you just told, why that asymptote is making that angle? I will show you the logic behind it. Okay. Just trying to draw something. Let's see if I can do it. Okay. So say I have some pole over here. I have some pole at this point. I have a pole at this point. What mark is it showing me? wanted a mark of pole. Okay. Oh, it is difficult this way. Don't know where it's coming single size. So this is a pole, okay. So this x represented over is a pole, and this is a 0 maybe, as you can see. You can see the pole and 0, right? This is a pole, okay. I consider this as a pole. Right now I am finding it difficult to find the mark, change the marker actually. Okay. Anyways, so you see, say you take a transfer function gs is equal to s minus s into s. And then let me write that down. Say I'm taking a transfer function like this, okay. So I'm saying a transfer function is something like this. Is s minus of a, cs minus of p1 s minus of p2. Okay, so there are two poles, and say there is only 1 0 over here. Okay, there is only 1 0, and there are two poles. Maybe there is another pole, maybe over here. Maybe at the origin I am placing another pole. At the origin there is one pole, and there is another pole over here, and there is a 0 over here. Okay, so you see, say I am taking a point which is very far away from this open loop poles and zeros. Okay, what will happen in that case? What would happen in that case? So this is that vector, right? So what does s minus p1 means? What does this s minus p1 means, Anubhav? What is this s minus p1?
So it tells about the pole P1.
It is actually a vector. If you look at this plane, if you look at this complex plane, say if this is p1, say this is p1, okay, so s minus p1, say s is at somewhere at infinity, maybe over here or maybe somewhere over here. At infinity there is some point. Okay, so s minus p1 is a vector which is subtending from this point to this one. So s minus p1. Similarly, s minus a is a vector which is from s is over here and this a. So s minus a is this vector. Right. S minus, say this p1, so s is at infinity. So s minus p1 would be another vector. So what is the angle subtended by this vector? What would be the angle? So angle of gs, the angle of this gs, that is what I call argument of gs, arg of gs, arg of g, that is equal to angle contribution due to this vector s minus a minus of angle of this vector, that is s minus p1, minus angle of s minus p2. Right. Now if this s, if this point s is lying on root locus, that means this angle must be 180 degree, an odd multiple of 180 degree. So odd multiple
Sorry,
of,
sir.
so what did I say? I said that s minus a is a vector. I mean, so if this a, s is any point in this complex plane. So say s is this point, say this is the point. So s minus a would be a vector from here to here. This is s. Okay. Are you getting my point? What I am trying to say? This vector,
Yes, yes.
I don't know why the nothing is working today. I do not know what has happened today. Nothing is working. This is also not working. Nothing is working. Reverse arrow, forward arrow size. So it's, I don't know. Anyways, leave it. Today my time is not good. Anyways, see, it's not working. Oh, I need to buy some iPad or something. It is difficult for me to conduct sessions like this. Anyway, so this is a vector. So this point over here. So this point over here is S. Okay, this point is S at this point. This point is S. So you understand this is S minus A, right? So this point is A. If this point is A, so this vector that I am talking about is S minus A. Do you understand that, Anubhav?
Yes, yes.
So, so if this is S minus A vector, what did that line go now? What is happening today? There is something seriously wrong with the software today. Oh, too difficult for me. Okay. So this was a vector I was talking about, S minus A. I closed the this inks that IP software because it's not working today. I do not know what has happened. Maybe because so many softwares are running at the same time. So what I was trying to say was, so if this S is a point which is lying on root locus, so if I substitute that point on root locus into this expression, then the angle of GS would be odd multiple of 180 degree, right? Right, Anubhav? You are getting my point?
How it becomes odd multiple of 180?
If I ask you to prove whether a point is lying on the root locus of GS, how do you prove it?
We, we satisfy angle and magnitude criteria.
What is the magnitude criteria? Or what is the angle criteria?
2n plus 1 into pi. Okay, sir.
So that is what?
180.
That is odd multiple of 180 degree, right? So if a point is lying
Yes,
on
sir.
root locus of GS, so the asymptote, what we say is when k is very high, when k tends to infinity, the poles of the system would follow that line. So if that line, so that line is a part of root locus. So if I am to put, if I am to put the value of S, we are very far away from the origin, then it should satisfy the criteria of the root locus, that is odd multiple of 180 degree. So that is why I am saying when k tends to infinity, this any point on the root locus, if I substitute that in this GS expression, then we will find that the angle of this GS would be an odd multiple of 180 degree. Now as these vectors S minus A, S minus P1, S minus P2 and S is lying very far away, so this angle would almost be equal. And the reason I am saying this is I need some board or something to explain all this. It's very difficult to explain like this. Just give me a minute. Let the Inkscape open up. Okay. So there is a pole over here. There is another pole over here. There is maybe some zero over here. And maybe some, let us forget about zero. Let us keep another pole itself. Okay. So there are three poles you can see, right? There are three poles you can see. The thing is, if S is a point very far away from this origin, then what is the angle subtended by it? Are you getting my point, Anubhav? See, look at these angles. If this point S is far away from the origin, then
I get it.
these angles that you see over here, these angles, this angle, this angle, then this angle, these angles would be very close to each other. These angles would be very close to each other. They are almost equal. So if they are equal, then what do you get? So you see, so if theta is the angle, say theta. So if the angles are same, then who is contributing to the positive angle? That is the zero. Say there are m zeros. So m minus number of this theta which is contributing to the negative of this angle. That is the number of poles. So say there are n poles. So you get theta equal to theta into m minus n. So this theta becomes equal to odd multiple of 180 degree divided by m minus n. That is why you get the angle of asymptote that you are talking about. This is how you get the angle of asymptote. Did you understand this? It is very difficult for me to express without a board or something. It is really very difficult, and I do not have any iPad also. That is another problem. But yeah, I will. I tried my best to explain. Anubhav, is there any confusion, or if you have not got anything, please tell me. I will repeat again.
Sir,
Did you understand, Anubhav? If you have not understood, please tell me. I will repeat the entire thing again.
I'm getting. I just remember the formula angle of asymptotes.
Yeah, I'm
Theta
asking
is.
how has that formula come? You have to know what is the philosophy behind the formula. Anyways, this is extra information I just gave you. So this is how the formula has come into existence. So this angle, so this is so you understand this is the angle which is contributed by the zero. This is the angle
This
which is
is
contributed by the pole of the system. This is the angle contributed by another pole. So say if there are n number of poles, then that will contribute to the negative of the angle. So minus of n. So let us represent it by the number of p. Number of p is the number of
okay, sir.
poles.
I got that.
So this is how that formula comes actually. Anyway, so you are stuck with that sum, right? So what was the acha? So this the GS has been given to you. First, what you do is you need to find the characteristic equation of the system. That is 1 plus GS. So after finding the characteristic equation, you write k in this term, and after k in terms of s, and after that to find the breakaway point, you take dk ds is equal to 0. Can you tell me why this dk ds is equal to 0? What is the reason behind this? Anubhav, can you tell why are you doing this? Okay, so I would ask you to think about it. Maybe in the next class, I will ask you this question. Where from have you got dkds is equal to 0? Why are you doing dkds is equal to 0 without understanding why are you doing it? Just read if you can find somewhere, spend a bit of a time and try to answer the question. Why are you writing dkds is equal to 0? Anyway, so you find dkds is equal to 0. After that, you get the quadratic equation. You get two roots of which one of them would not be lying on the root locus. So this would be the correct option. The option is A that you have already told me. There's not much to the question, but these things that you need to know. These are the things that you have to know where from these conditions are coming.
Sir,
Yes.
I have read the theory last year, so theory part I start forgetting. I need to revise it again because we are continuously solving problems, so it becomes habitual.
No, no, I am not continuous, bro. I am not. I have appeared for GATE in 2015 or something. That is a quite a long time back. After that, I did job. I left job. I came back to IISc. I am doing PhD. A lot of things I have done, and this is after 5-10 years. I'm doing this sums again. It is not like I am in continuous practice. But once you do it, it gets imprinted in your mind. You cannot forget those things. But thing is that the things these are the things that are extra addition when you come to the class, because this reasoning you will not find in any book. You will not find explanation in any book. Okay, why have you written the you can find the formula. You can find, you can easily put dkds is equal to 0. You can get that 180 divided by p minus z, but you would never know why are you doing it. Blindly doing something is kind of mechanical stuff. That is what a machine does. A human being always asks questions. Why are we doing it if you are doing it that way? So I am not but solving. I mean, thing is that we are all PhD students at IISc, and we do not solve gate questions. We have a lot of work to do. If you get into institute, you'll understand what pressure each and every student over here in the electrical department or EECS division are in. So you will have class every day, you will have assignments, you will have this lab exercises. You would hardly find time to sleep or have your food or take bath. You would hardly find any time. But still we are asked to do this by NPTEL. That's why we are doing it, this gate stuff. We are not at all in practice for a long time, but these concepts are we have these concepts with us, so we can help you out. That is the thing. So you don't need to be in practice to answer questions in gate all the time. For performing in competitive exam, you need it because there is a time frame. You will be getting 3 minutes of time to solve a question. But for understanding what you are doing, for the way you are solving most of the questions, I have seen previous class also, that the expansion of e to the power minus s. You never question why e to the power minus s is 1 minus s that you are doing. So that way you can solve a gate question. But again, in the long run, it is going to be of no use because you haven't understood what you have done. You are just mechanically following steps. That would be difficult, at later stage. And I do not. If you are interested in research, then it would be difficult because you have to answer for each and every step that you are doing. Like in root locus, there are a bunch of rules that has been given to you. Say I'm asking a simple question. Say there is a root locus. Okay, so I'm a very simple question I'm asking. Say there is a root locus that is already given. Uh, this pen and all these things really. Wait a minute. Let me just. So I'm showing you one root locus. You just tell me what would you do in such a case. These gate papers, what are I open? Let me see. Okay, these are root locus. Yeah. Here, you see the root locus over here in the picture.
Yes, yes.
Say this is a root locus of a system that is that these are root locus of plant that you have with you. Now you want to design a controller such that the root locus passes through this point. Say this is the point I want the root locus to pass through. So there would be another conjugate of this point. So I want the root locus to pass through like this. I mean, like this. I want it to pass through like this. How would you achieve this? How will you do this? Ultimate aim of any control system engineer is to design a controller which would give you the performance you want. Now, say your employer has told you that I want a system whose dominant closed loop poles are at this region. These are the regions where the dominant closed loop poles should lie. What would you do? What would you do, or how would you design the controller so that the root locus would pass through this point? How do you do that?
We add 0.
Add zero where? Any other suggestion other than adding zero?
Sir, the ultimate aim is to increase the angle of asymptote.
What ultimate aim is to increase the angle of?
So asymptote.
Okay. What will you
So
do to do that?
so we increase the difference. So decrease the difference between pole and zero.
Yeah. So these are the planned poles and zeros. You cannot alter this. This is a plan you already have. You have to either add something. What will you add? Where will you add? And how would you determine what to add? There are two ways actually. I can tell you two ways by which you can do it. One way, you see, so the one way is the condition that I told you just now. The thing is that if the root locus has to pass to this point, that means this point must satisfy the angle and the magnitude criteria. Okay. So what you will do is you would find the angle that this pole is subtending at this point, this pole is subtending at this point, and this pole is subtending at this point, and you will find what deficit. So this, if this was in the root locus, your total angle must be minus 180 degree, or multiple of 180 degree, or multiple of 180 degree. You needed that, but as it is not in the root locus, not right now, so this would not be 180 degree. There was something other than 180 degree. So say that is theta. Say that is theta. So what you will do is you will find theta minus this thing, or 180 degree minus theta you have to do. You will find the angle deficit. So that angle, so say angle D, theta D is the angle deficit. So that phase you must add to this system to get the root locus to pass to that point. That may be 0, that may be some other thing, whatever it is. You have to find the angle deficit that it has, that you need to add so that the root locus passes to this point. Once you get that, what is the next step that you will do? You have found the angle deficit, and based on that you have added some poles or zeros, whatever you have done. Now this point would be a point on the root locus. Now what would be your next step? What will be your next step to? Very simple. What would be your next step to design the controller?
Satisfy the criteria, magnitude and angle criteria.
Magnitude criteria. You have to find the value of k. What value of k you need for the for operating at this point. So once you find the value of k, you add a controller k divided by s minus p1 s plus p1 or p whatever it is that you want to add as a controller. So you add that as your controller, and then you design the controller. This is how design is actually done. So things that you read or whatever you have studied, those are just tools, but there is hardly any course which teaches you how to use them. Maybe you would learn that at masters or somewhere, or in your master's course or postgraduate course, but this is the main logic why root locus is important to us. It gives you information about the dominant pole dynamics. Bode plot which is not going to give you the dominant pole dynamics of the system. It will only tell you about it will only help you in achieving the performance criteria, where the frequency range for which you need a high gain, frequency range for you need a which you want to reject, the disturbance rejection. So those things will help you, but dominant pole dynamics is not represented, or there are several questions which cannot answer through Bode plot. So root locus gives you complete information about the closed loop dominant pole dynamics. So this is the ultimate aim. Your aim as a control engineer is to design a controller, not just if you're solving a few sums. They're just tools. Anyways, that's a different thing. But this is the basic concept. You have understood why I'm worried about not understanding what steps we are taking.
Yes, yes.
Okay, then today let us stop, because attending there is hardly anyone who is attending the classes. Let us stop today. It's already 7:52.
Thank you, sir.
Okay, man.